Hello, 7th grade. Sorry I can't be there with you today. However, I do want to say congratulations on your last quiz because that was awesome. You guys did great. So hopefully this chapter is going to continue to go really well for us. And I think this gives us a really good indication of how algebra is going to go for us next year too, because I just think this is so much fun. So I think we're going to do really well with it. So lesson 12.5. We are on page 536 if you want to follow along in your book. If you need to take any notes, just ask for the video to be paused. Don't be afraid to raise your hand. Just say, hey, pause that for a second so that you can finish taking your notes. I'm not going to pause for you to take notes because then I'd have a 30-minute video, but you can hit the pause button as many times as you need. So this section is on solving equations involving addition and subtraction. And lucky for us, I know for a fact we spent a whole chapter on this in 6th grade. So hopefully this will kind of come flooding back to you, or maybe it's still fresh in your brain. If you don't remember it, that's okay. This just gives us a second opportunity to go in and make sure we have it this time around. So first up is a definition of a solution. A solution is a number that when substituted for a variable makes an equation true. Let me give you a quick example before we go on to the book's example. So my example would just be x plus 2 equals 5. If I went ahead and said x equals 3, remember we were evaluating before in the last section, or in the first couple sections of this chapter, where we would just take this x equals 3 value, substitute it in, and evaluate. So this would be like saying 3 plus 2 equals 5. Well, 3 plus 2 is 5, so 5 does equal 5. So that means, yes, this is a solution. That is what it means to have a solution. Whenever you say, all right, let me go ahead and take out this, and if it makes both sides of your equation true, then it is a solution. So example 1. Is 14 a solution of s plus 23 equals 37? So all we're doing here is evaluating. We're taking out our s and we're substituting in a 14. 14 plus 23. So what we're wanting to do is get everything on this side to be equal to this side. And if it is, then it's a solution. If it's not equal when we're done, then it's not a solution. So we're just going to do order of operations on this side. 14 plus 23 gives us 37. And then we just bring down our 37 on the other side. So yes, 37 is equal to 37. So yes, 14 is a solution of this equation. So skill check 1, determine if the given value is a solution, right, yes or no. So go ahead and try a couple of these. They're giving you an equation. Remember, an equation has an equal sign in it. That's how it's different from an expression. So your equation has an equal sign. You're going to sub in your value that they give you, and then say yes or no whether it is a solution. Now, because there's a lot of operational signs and equal signs and everything, I would go ahead and circle your value for your variable just to get it separate to keep you from getting confused on them. So go ahead, pause the video, take a few seconds to work these out, and then we'll go over the answers. Okay, so is x equal to -3 a solution? Well, we'd have to say -3 minus 5 equals -8. Remember, -3 minus -5 can be rewritten as -3 plus -5 equals -8. A negative plus a negative is going to give us a negative answer, and 3 plus 5 is 8, so we have -8 equal to -8. So yes, this first one is a solution. Next up, we have 18 plus 15 equals 34. Well, 18 and 15, 8 and 5 is 3, carry our 1, that gives us 33. Is 33 equal to 34? No, it is not equal. And whenever you see an equal sign with a slash through it, just like that, that means not equal. So going on to number 3 and 4, we have 12 times negative 6 equals 72. Well, a positive times a negative is a negative, so we have 12 times 6 is 72, and it's a negative. Is negative 72 equal to positive 72? No, these are not equal. And W equals 44, so we'll do 40, I wrote the W, 44 over negative 4 equal to negative 11. Remember, whenever we see a fraction like this, it's like a division problem. 44 divided by 4 is 11. A positive divided by a negative gives us a negative. So is negative 11 equal to negative 11? Yes, it is. Now, one thing that I would recommend is taking your hand and placing them over this portion, the equals part, while you're working it out so you can't see it. So I would lay my hand on top of that or lay a piece of scratch paper, something, so that you don't just automatically see that number, rush through it, and say, oh yeah, they're equal. Because sometimes if you get a number stuck in your brain, like of what your goal is, that can throw you off. So I would cover up what it's supposed to be, work out the expression on the opposite side, and then lift your hand or lift your paper and see, are they equal? I think that's probably the safest way to do it to make sure you don't just get inside your brain a little bit too much. So when you're solving an equation, if you perform an operation on the left side of the equation, you must perform the exact same operation on the right side of an equation. So, no, let me grab my pen here. I don't know where it went. Here we go. So think about it. Have you guys ever seen a scale, like a law firm symbol type deal? Maybe you've seen them at church even. Oops, there we go. Where it's like a balance, so it has to be balanced in the middle. So I actually had this really cool illustration I was going to do. You could probably do it there on your own. If you take a ruler and you balance it on your finger, so picture it with me. Here's your ruler. It's hanging on your finger here, and it's perfectly balanced. If you hang a paper clip on one side of it, guess what's going to happen? This side's going to go down. So in order to balance it again, you would have to do the same exact thing to this side to make this side go back up. They would have to still be balanced. So whatever you do to this side of your scale, you would also have to do to this side of your scale. Likewise, if it was opposite, if we would have put it on this side first, we would have to do the same thing on the other. This is what this is saying. It's the same thing with the equations. We can call it the golden rule of equations. You've probably heard of do unto others as you would have them do unto you. Well, this is do unto one side of your equation. As you do to the other. Because this is like our equation, and there's the equal sign in the middle, and they have to remain equal to each other. Both sides have to remain equal. So if we're adding something to one side, we have to add it to the other. If we're removing something from one side, we have to remove it from the other. Same thing goes for multiplication or division. Whatever you do to one side, you have to balance it out by doing it to the other, because both sides always have to remain equal to each other. When solving an equation, you must undo the operation that is performed to the variable. So we kind of did this a little bit when we were working on geometry. We're going to get more into it now. So to do this, you use the inverse operation, such as addition and subtraction will undo each other. So let's just talk about our inverses real quick. If I add, the opposite or the inverse of that is to subtract. If I subtract, the opposite or the inverse of that is to add. If I multiply, see if you can guess it. If I multiply, we're going to divide. And if I divide, then of course the opposite or the inverse is to multiply. So it's important to know your inverse operations. So we're going to go through these steps, but we're not really going to pay too much attention to them until we actually see a sample, because we know that's how it works better off. So these are in your book if you want to go back and copy them later. But for right now, let's just go through them. And then we'll look at them in detail with an example. So identify what has been done to the variable, use the inverse operation to undo the operation identified, and then check the solution. Simple enough, but we still want to just make sure we've got it down pat with an example. So example 2 says solve this equation. So what we're doing when we're solving is we're actually looking for the solution for n. What is the solution for n? That's why there's a difference between whenever we say we're evaluating, like when we would evaluate an expression, we're not technically solving it. This is when we're solving it. When you solve, you are finding the solution. So, first things first. And I'm not gonna use their animations. I'll just fly through them at the end. I'm gonna actually work this out with you. So if we have 9 plus n equals 32. First we need to know what is happening to our variable. I like to circle my variable so I can get it in my mind where it is, and we want the variable all alone on one side and everything else on the other. So our goal is to get rid of this 9. So it's a positive 9. So how could I get rid of a positive 9? I can subtract a 9 or add a negative 9, either way. However you want to think of it, whether you're subtracting 9 or you're adding your negative 9, either way works. So this is how we do it in our class to just kind of see each step as it's happening. So we have 9 minus 9. So then I also like to draw a dotted line until we get used to this, so you can see where your equal sign is, see where your equation is divided up. So we have 9 minus 9. That means we have to also subtract 9 on the right-hand side. Now, whenever we do 9 minus 9, we get 0. And then we have our n left. So now we have n equals 32 minus 9, which is 23. And then that gives us the solution for n. N equals 23. The final step is just to check it. You should always, always, always go back and check it. To check it, you're just evaluating. You're taking this 23, you're substituting it back in and double checking. So we'll say 9 plus n equals 32, where we say n is equal to 23, so 9 plus 23. This is where I would be covering up my answer to make sure I have the right thing in here. So if you need to, you can do scratch work over to the side. Let's see, 3 and 9 is 12, carry our 1, 2, and 1 is 3, so we have 32. So I have 32 equal to 32. Yes, my answer does check out. So hang on while I go through and zoom through these animations. Example 3. 12 is 4 more than a number. Find the number. So this is translating our sentence into an algebraic equation like we were doing last time. But now, remember you kept saying, should we solve it? Should we find the number? Well, now we're going to find the number. So we have 12 is. That means 12 equals 4 more than what I started with. And what did I start with? I started with a number. So that means it's a number plus 4. So my equation is 12 equals n plus 4. Now I have n plus 4, so I need to think inverse operation. I'm adding something to my n, so I need to subtract 4. Because remember, my goal is to get n all by itself. So whenever I subtract 4 from one side, I'm subtracting it from the other. 12 minus 4 gives me 8. 4 minus 4 is 0, so I just have n. N equals 8. You should always go back and rewrite it the proper way to read it from left to right, like we were reading a sentence. N equals 8. So if it ends up backwards, that's fine. Just go ahead when you present your final answer, flip it around. So n equals 8, and then we should check it. So we have 8 plus 4, which is 12, and I was going for 12, so 12 does equal 12. My answer does check out. Now I want to just take one quick second here. I want to talk about how your book shows you to solve these. We're doing the same exact thing, they just write it a little bit differently, and sometimes it can get a little bit jumbled, but just so you understand what they're doing versus what we're doing, I want to show you. So they wrote 12 equals n plus 4, just like we did, and they subtracted 4 from each side just like we did, but they actually rewrote the entire line out again. So theirs looks a little bit more like this. They rewrote 12, then they subtracted 4 equals n plus 4 minus 4. If you're more comfortable with this way, this is actually how I learned to do it. So if you're more comfortable with this, that's fine. You can go ahead and do that. I just prefer to see this kind of broken down so you can really focus in on one step at a time. We subtracted 4 and what we got. But if you prefer this, that's fine too. It's not exactly what I would recommend though. But so you can see, so they did the 12 minus 4 equals n, or equals n, plus 4 minus 4, so 12 minus 4 is 8, 4 minus 4, those cancel out, and you end up with the n. Either way, whatever you're more comfortable with, but if you asked my opinion, I would say this method for sure. Especially if you're using Khan Academy and you want to see any extra work, this is what they use also. So it might help you out to just choose one method and stick with it, and I know that this is how Mr. Khan writes out his stuff also, so if you're doing that extra work at home to kind of like practice, I would go ahead and just stick with the one method. Alright, let's fly through their animations, and then skill check 2, so go ahead and try these, and then pause the video, and we'll come back and double check. Okay, so the answers for these. We said b plus 7 equals 22. I want to get the b all by itself, so I have plus 7, so my opposite, or my inverse operation is to subtract 7 from each side. Again, feel free to put your dashed line in where your equal sign is, just to separate your two sides while you're getting used to doing this. So I have b, 7 minus 7 is 0, so we can just leave that blank, and then 22 minus 7 is 16, so we have b equals 16 for the first one. The second one we had n plus 13 equals 40. So we want to get n all by itself on one side of the equation. We are adding 13, so our inverse operation is to subtract. We end up with n equals 27. And the last one, 9 plus w equals negative 3. Now if this throws you off, you can say, well, this is a positive 9, so I need a negative 9 value, or to subtract 9. Or remember our commutative property, whenever this is addition, and addition only, for right now, addition only, if it just makes you more comfortable to see w plus 9, because it's a positive 9, you can flip those around. We're adding these two numbers, 9 plus w, our commutative property says I can flip them around and it's the same thing. So we could flip it around if that makes you more comfortable. So I'm getting 9 by itself, subtracting 9 from each side. Now, on this one, we have a negative 3 minus 9, which is the same thing as negative 3 plus negative 9. We end up with w equals negative 12. And then solving equations involving subtraction. So identify what's been done to the variable, use the inverse operations, check the solution. Same exact thing as we did before. So solve this equation. This time, this is subtraction. Remember, if we say a plus negative 18, that's the same thing as saying a minus 18. So this is technically the same equation, a minus 18. So if I have negative 47 equals a minus 18, if I'm subtracting 18, the inverse of that is to add 18. So I'm going to go ahead and add 18 to both sides. Remember, when we have a negative plus a positive we have to subtract and keep the sign of the larger. So we have on one side a negative 18 and positive 18, or minus 18 plus 18 gives us 0. And then if we need to, we can go back over on the side here and do a little bit of scratch work. So we have 47 minus 18. 17 minus 8 is 9. 3 minus 1 is 2. So we have 29. Keep the sign of the larger. So 47 has a larger absolute value than 18. 47 was negative, so it's going to be negative 29. So we have A equals negative 29. And then you should go back and check. So we have negative 47 equals negative 29 plus negative 18. We're just going back to our original and substituting in the value where we have A. Remember, a negative plus a negative is going to give us a negative answer. 8 and 9 is 17. Carry our 1. 1 and 2 is 3, plus that 1 is 4. So we have negative 47 is equal to negative 47, and our answer checks out. And then last but not least is example 5. It's just another one where we have to translate it first. So we have 5 less than a number is equal to 19. Find the number. So 5 less than a number is 5 less than what I started with. What did I start with? I started with a number. So I have a number minus 5 is equal to equals 19. So I'm subtracting 5 from my end, so my inverse operation would be to add 5 on both sides. And my minus 5, or my negative 5 value plus 5 cancels out, equals 19 plus 5 is 24. Go back and check. 24 minus 5 equals 19. 24 minus 5 is 19, so that does check out. And finally, skill check 3. So solve each equation. So go ahead, pause the video, and then we'll check our answers. All right, so we have c minus 8 equals 25. My inverse operation would be to add 8 to get c all by itself. So I have to add 8 to both sides. So I have c equals c 8 and 5 is 13, carry a 1, so we have 33. Then we have r minus 14 equals negative 3. So my inverse operation would be to add 14. So we end up with r equals, 14 on both sides. Now we've got a positive value and a negative value, so we have to subtract. 14 minus 3 is 11. Keep the sign of the larger. 14 has a larger absolute value than 3, so it's a positive, so it's positive 11. And last but not least, negative 48 equals h minus 12. H all by itself, the opposite, or the inverse operation would be to add 12 to both sides. So I have h equals, and then again I have to subtract, keep the sign of the larger. 48 minus 12 is 36. Negative 48. 48 has a larger absolute value than 12, so it's going to be a negative. So it's h equals negative 36. So hopefully those are the answers you got. If not, you can email me today if you have any questions about the lesson. Just email me from your school email. It's rritchie@mymariah.org. And it does come to my phone, so even though I'm, at home, I can check it, no problem, and I can get right back to you. I can even do an extra little video and send it back to you if you just need something explained a little bit better. Just let me know. Otherwise, I will be in on Monday. So one last thing real quick, let's look at your assignment. Now, it's not actually homework, but I'm sure you'll have enough time to get these completed in class today. Make sure you are going back and checking your work, though. So I would do 1 through 15 and have Mrs. Brown check them. Go ahead and show her where my teacher's manual is behind my desk. And then go ahead and finish 16 through 38. I don't think you should have any problem finishing that before the end of the class period, but if you don't get it done, it's not homework, of course, because it's the weekend. Just do your best to get them finished, though, so that we can go over them on Monday. All right, guys, have a good weekend.